right, how's it going?
Sounded so wrong.
Okay, thank you. So questions?
I have really embarrassing questions that make me feel like I haven't been paying attention to class, but I have been.
Okay. You can bring a sock puppet and have the sock puppet ask
I'll
questions
ask
if you want.
Class.
Do you want me to ask an even dumber question?
Yeah, that kind of makes me feel better.
How do pointers work?
Okay.
Yeah, okay. In what sense?
So what do they store?
They store an address.
Okay. Was that
So-
good enough, Rich?
No, damn it, no.
Go for it, man.
If I were to say, so like, how does get car work?
You're not the first person to ask
No.
me that today.
Okay, like, so it works as a function. Say C equals get car, right? And then so you save it to C, right? But then you're like, how do you increase it to the next character? Well,
Next time you call get car, it'll get the next character.
automatically does it?
Yeah. So
Okay.
every time you call get car, paren, it ingests another character.
And then say you save it to this 2D array, right?
Okay.
And then so like, how do you what?
Yeah, how do you do anything with that?
Do you do it like IJ and then I++ or J++ depending on whatever? Just declare them as integers?
Yeah, so let's spin some code here.
We're not alone with that question. My life around.
He just wants to update his stuff.
What?
He's trying to update his Discord status.
Oh, you're giving us a little hint there.
So let's just write a sample of this. So I'm going to pretend that we have this get phrase function. All right, my main program is just going to call get phrase once. It's going to print out what it returns. And let's just write get phrase to call get car until we find a $sign. Okay, totally random thing to do.
Answer my own question. Go ahead.
Okay. So we need an output location, right? Because we're going to read with get car, and each time we read something, we're going to store it into this output array until we get to this $sign. So we'll read the first character as usual. And while this character is not a $sign, so that's the end of our phrase, right? While it's not a $sign, let's just save this in the output array. So output bracket out location equals ch. So ch equals get car, that reads the first character. If it's not a $sign, we're going to go ahead and we're going to save it in our output array. Where do we save it? Well, initially we save it at location 0, because that's what outloc is equal to. And then we're going to increment outloc. So now the next time we read a character, we're going to save it in location 1. And the next time we read it, we'll save it in location 2. And so on. So here's our main ingest loop, right? Get a character, if it's not a $sign, save it in our output array, increment the location in the output array for the next character, and call get car again. And each time we do this, we read one character from standard in, and if that character wasn't a $sign, it'll get saved. we'll bump up our output location, we'll read another character. At some point, we'll read a $sign, and when we come up here, it'll say, well, that character's not a $sign. Well, that fails to be true, so it exits our while loop. So we end up down here. So we're assuming that's the end of our phrase. So we got to add a null terminator to our output. And if I use output location like this, I'm always thinking output location is where the next character goes. So right now, outloc is where the null terminator should get stored. So I'm going to say output bracket outloc equals null terminator. So that's a example of a different kind of get phrase. It should just read input until we find a $sign. So let's see what this does. Oh, look at all them errors, man. Okay. So in this case, we said our phrase is terminated by a $sign, it read up to the $sign, and that's all I put in the output array. And I can do this a bunch of times. And I'll get some errors at some point, but oh, that was poopy.
It
Yeah.
said that you use capital G when you try to tell the compile.
Did I? Thank you. There we go. That would have taken me like all day to figure out. Right? So they're you know, we're splitting this thing up at the $signs.
And it'll continue doing that loop until...
So I'm not dealing with end of file in here. That's kind of an embellishment.
Yeah.
But just as something that uses getCar and saves what it's getting with getCar into an array, right? That's a pretty good framework. It's really this right here that's doing the main action. Because you can call getCar, it gives you a character. That's your only shot at that character. If you call getCar again, it's going to read the next character in the input. So you call getCar, you can save it in something like CH, right, or C or something. But if we're trying to build up a phrase, right, save it in an output array.
And then when we plus outload, it gives it the next address.
Gives it the next
array.
address, right. So the first time through, it's saying output bracket 0 equals CH. The next time through, it'll say output bracket 1 equals CH.
The tricky part for me is when you get into the second dimension.
Oh, don't worry about that for now. You don't need that for your phrase parsing. Okay, your phrase parsing, your goal is just to read a phrase, right? It was the best of times. There's my phrase. Call get phrase again, it says it was the worst of times. There's your next phrase. Yeah?
I'm still confused how getCar decides where to read from.
Reads from standard in.
But you can change that?
Yeah.
By pipes or...
So if I just say go 3, it's just reading from my keyboard. Right, but if I say go 3 less than a file, then it's going to read from that file. Right, I didn't write my code very well. but it basically ingested everything up to the first dollar sign, and that was my first phrase. It was just a really big phrase. And if you type in some command and you pipe it into your program, then it reads standard in, get Carl read from the output of that program you piped into it. So standard in has different sources. Right, in this case, get Carl read the output of this command. In this case, get Carl read the contents of this file. In this case, get Carl read from my keyboard. Those are usually the three main sources.
So when you ran the program on itself, you got a segmentation fault.
Yeah, because my phrase got too long.
Oh, yeah. So if you change it from being a dollar sign to EOF, will it just run and then print out the entire thing?
It would print out the entire thing,
Okay.
yeah. Let's look for a space. Alright, so it got number sign include, it got stdio.h, it got a new line void, it got a character, it got a star, and so on. So it's breaking it up at spaces now. Alright, but back to what we were talking about. Where were we? 'Cause you had asked something I didn't quite finish answering.
Going to the next.
Oh, the two-dimensional thing.
Right.
Yeah. So your first task is to make a phrase getter, and that just returns a plain old one-dimensional array of characters, just a string.
Okay.
Okay. After you've got that, then you want to do something like make a save phrase, and you pass it your phrase that you just got with code like that. You pass it your dictionary, which is your two-dimensional array. And you pass it your counts, which is a one-dimensional array of integers, and you pass it something that tells it how long those arrays are, like dictionary length. And so now, sort of a mix of pseudocode and C here. Make a for loop, I equals 0, I less than dictionary length I plus plus, if dictionary bracket I matches phrase, then increment counts bracket I and return. So go through all the entries in the dictionary and look at each entry, 0, 1, 2, 3, right? Dictionary bracket I is a string, phrase is a string. If they're the same string, then we've already seen this phrase, just bump up the count that corresponds to that phrase, which is element I in the counts array. Right, so increment counts bracket I. If you come all the way through this loop and you haven't returned yet, it means this is a new phrase, it's not in the dictionary. So now save phrase as a new entry. And set the count equal to 1. Okay,
Go ahead.
so how do you do this comparison? That's string compare. So string compare dictionary bracket I, comma, phrase. If it returns 0, they match.
Right.
So in that case, increment counts bracket I and return. If you come all the way through, you need to make a new entry in your dictionary. And that new entry is going to go at dictionary bracket dictionary length. So string copy dictionary bracket dictionary length, comma, phrase. Counts bracket dictionary length equals 1, and then increment dictionary length. And that adds it to the end of the dictionary. Does that make more sense?
Right.
Okay. But do the phrase extractor first. Or do this first, but just hand it phrases yourself.
And so the dictionary length would determine how long the second to next one.
Yeah, so initialize, dictionary length to 0.
Right.
And dictionary is a 1000 by 201. Phrase is just a character 201. Counts as an array of 1000 integers. And You should be able to just call save phrase hello, goodbye, ta-da. Right, and then when you're done, dictionary should have 3 things in it. Hello with a count of 2, goodbye with a count of 2, ta-da with a count of 1.
This is kind of a weird question.
Mm-hmm.
Are we saving these to a separate file for the dictionary?
No, it's just a big memory array.
Yikes.
So it's just a car 1000-201.
Is it necessary to modularize this?
No.
No.
I mean, I would make a function for ingesting a phrase. I'd make a function for saving a phrase. You could put it all in one file. That's fine.
Okay.
And that's only 200 kilobytes. It's not.
So we're never going to actually physically see what's in the dictionary.
You can.
Until we test it.
Yeah. Yeah.
Okay.
Would there be a way to? Because that's saying that you have 1,000 elements that each have 200 elements, or 201 elements each.
Mm-hmm.
Would there be a way to make it so that each of the 1,000 elements have varying?
Mm-hmm.
Okay, and you
Yeah.
can just read a phrase and set the length of each individual element.
Mm-hmm.
Would there be any pluses or minuses to that?
Pluses is it will win you karma points in the magic realm of programmer karma.
Cool.
You know, it's a good thing to be able to do. Downside is it's a hard thing to do.
Oh, okay.
Right. You're going to have to dynamically allocate memory,
Hmm.
and so there's many more ways you can go wrong.
Yeah.
Right. But you know, it's if you want to, if you're comfortable with PA4 and you know, you've either got plenty of time before it's due, or you've got something that you can turn in and you're ready to find the next level. Right. That's the next level basically.
Okay.
But it's a fair amount harder.
And then when we're talking about the dictionary, like if we pass the dictionary to another function, does it do a pass by reference or pass by value?
So that's where it starts to get a little harder. So I believe it passes by value if it's just 1,000 by 201.
Okay.
So
can you do
kind
a
of.
pointer?
I mean, it's by reference and by value are confusing when you talk about arrays. Technically, it's passing by value no matter what you do. But the
Right.
value it's passing is the address where that array begins.
Right.
So if you modify that array in your function, it takes in the calling program's copy.
Okay, so if you have like a sort function, if you have the dictionary in your main function, and you have the sort function, and so when you send your dictionary to the sort function, you need to send the like dictionary that you have that is sorted back.
Yeah, it'll happen automatically.
Oh.
So if you call, so here's your main program, and here's your dictionary. And you do stuff, and now you say sort D. Okay, so in your sort function, right, and you say something like in bracket I plus 1. Right, you make changes to this array. When you come back, those changes have been made to D.
Isn't that pass by reference?
That's technically passed by reference, but yeah, but it's passing the address of D by value.
Yeah.
Yeah.
But an array is a reference.
An array.
It's like a pointer. So that's
Technically,
why.
yeah.
You're just holding down D there.
Say what?
Were you holding
Yeah,
down
yeah.
D? Okay.
All right, so there's our simplified bubble sort. It just swaps elements 0 and 1. So d bracket 0 is 10, d bracket 1 is 20. We'll print those out, and then we'll call our sort function. And then we'll print them out again, and it should swap those.
Int. Yeah.
It's not in.
It,
Is that a new variable name?
That's a new variable type. I'm getting lots of errors for my money here. Yeah, there we go. All right, so that does swap.
well, we're doing
So let's run this in GDB. So GDB was called with in, which is this big, long, scary hexadecimal number, right?
because it has 1,000 elements.
Yeah. So what we find there is the number 10 followed by the number 20. So when we call sort, when we say sort parentheses D, it passes the address of D, right? Which we call by reference, but technically it's by value.
So instead of saying void sort int d or d1000 or in1000, you could just put a pointer reference.
So for a one-dimensional array, I can get away with this. Right, and this will work exactly the same. Right, so it calls sort and it passes it the address of that array.
But then you couldn't look in specific elements of that then. Like you couldn't do the bracket.
You can, I mean, I'm doing that inside sort.
Yeah.
Even though in is an int star, I can say in bracket 0, in bracket 1. Okay, here's the thing though. It's not the same for two-dimensional arrays.
Can't do star star.
You can, but it's not the same thing as bracket bracket.
Well,
So here's an integer a55, and I'm going to go through and I'm going to set element I comma j equal to 10 times I plus j. So element 2 comma 3 should have the value 23. Element 4 comma 1 should have the value 41. So it is easy to spot these values. And in the first case, I'm just declaring an integer a bracket 5 bracket 5. In the second case, I'm doing an integer star star. And if you don't want to do dynamic arrays for PA4, which I don't recommend you do, don't worry too much about this because we'll chow on this in 222 at length. All right, so if I print out A, okay, GDB knows what A is, but let's look at the address of A. A is stored at this location in memory. Let's examine that location in decimal. What do I find? I find a 0, 1, 2, 3, 4, followed by 10, 11, 12, 13, 14, 20, 30, and 40. So here's what's happening there. When I say integer a bracket 5 bracket 5, A is pointing to somewhere in memory, and at that location I find the following. Right, I find the 25 elements of this A array sitting in memory, one right after another. 4 bytes each, 100 bytes total. All right, when I do an integer star star, it's a different story. So B is equal to another memory address. So B is pointing somewhere in memory, but if I look at that location in memory, I don't find my first element of the array.
You find a pointer.
What I find is a memory address.
It's an array of pointers.
Yeah, so A points to something which is itself a pointer. And if I look at this address, right, there's my 0, my 1, my 2, my 3, my 4. Followed by strange stuff.
Do we have to do it this way?
Nope. And I recommend you don't do it this way.
Got it.
So B is pointing to some location in memory where I find A 0, 0, 1, all the way down to 0, 4.
Whoa. And then past that, it's looking at a different spot. Next to B.
Right, so here's the next entry in B. And if I look at this location, right, there's my 10, 11, 12, 13, 14. So integer star star, B points to 5 consecutive 8-byte locations. And these could be in any random order.
Is there a reason why it decides to orientate it like that?
Probably.
Okay.
There's a reason for everything, right? Almost. Except love.
So, performance-wise, which would be faster?
Depends how you do it. I mean, the thing that people are kind of catching on a bit is the fact that every phrase is 201 bytes in memory. And, you know, most phrases aren't that long. So yeah, we're wasting a lot of memory. And when you do a string compare, maybe that's a bit of a factor also. But, you know, performance-wise, this star star would be more efficient. Although allocating memory dynamically is also a little inefficient, but it would probably be a win to do it like this. But it is a lot more complex, right? So if you want the extra challenge, you can go for it.
So, when we're living in like the today times and memory is so cheap and everywhere,
Yeah.
how much should we actually worry about this, or is that even a question that we should be asking?
So that's a good question to ask. I mean, for this assignment, right, 1,000 phrases, 201 bytes, that's like 1/5 of a megabyte,
Yeah.
right? And your computer has at least a few gigabytes of main memory, and it's got way more than that in virtual memory. So it's really a non-issue. Now, if you were trying to store 1 billion phrases, this becomes a bigger issue.
Yeah.
For one thing, when we use this static array declaration, right, all these things are sequential in memory. If we have 1 billion phrases, 100 characters each, we need to find 100 billion bytes of consecutive memory locations that are available. That's going to be hard to do.
Right.
But, you know, 1,000 by 201, not an issue at all, and time-wise, not an issue.
Unless you're trying to do, like, integrated stuff.
Integrated.
Like in circuits and stuff.
Yeah, yeah.
Oh. And so, like, if we were doing something like this in Java
Mhm.
that is running on like a virtual compiler,
Yeah.
how does that interact with memory, and would we worry about it?
Well, Java is in some ways smarter about things like arrays. But we would not use a two-dimensional array. We'd make an object called a phrase that would include the phrase itself and the length of the phrase, because that's part of strings and how many times the phrase occurs.
Okay.
and we would just have a one-dimensional array of phrases,
Hmm.
and that would work perfectly fine. And each phrase could be as long or as short as it needs, because strings can change length easily. They're not just arrays in Java,
Okay.
so it handles it really well.
But then you can do that as structures. You can just have a one-dimensional array of structures.
You can do it with structures and make it a one-dimensional array, but then you still have the question, do you want to do a 201 character phrase or dynamic?
Well, so for structures, because I'm trying to use structures, but I
Mhm.
feel like it's just the same thing as like two-dimensional array, except I have like a structure with an array and then
Yeah,
car.
it's hiding it.
Yeah, so then I have another question. So when we're going back to setting, like after we're done parsing and then separating like all the phrases out, and then let's say you want to set your temp phrase equal to into your structure, like is there an
Mhm.
easier way to do that without the for loop, or do you just have to
So you're trying to copy a string?
Yeah.
So there's a string copy function you can use.
We're allowed to use that?
Yeah, yeah.
Oh, okay.
And that's just a for loop, basically.
Okay.
Yeah, you can use string copy, string compare, string length.
String compare do.
Tells you which string comes first alphabetically. Yeah.
Oh.
Do you want it to be off?
Bubble sort is super easy.
Yeah, it helps with the bubble sort. Well, bubble sort,
Well,
you're
that's
sorting
right.
by length, not alphabetical. But if you wanted to alphabetize, you can do that.
But it's not required.
But string compare is how you tell if two phrases are the same,
Okay.
right? Because you can't say if string 1 equals string 2. That won't tell you if they have the same letters.
And you could use that for the, how you were doing it earlier with the two-dimensional.
Mm-hmm. Yeah.
Okay. Cool.
Yeah.
I had a question. Too stupid to remember it. I'm sorry.
So you don't remember it?
No.
Okay. Well, you will. Yeah.
I have a question. So I was trying to use GDB to find a segfault in
Mhm.
all of my code. But with this particular assignment that we're doing, we need something from either standard in or a file in order for getCard to work.
Mm-hmm.
I don't know how to get that file or standard in into
Yeah. I'm gonna have to post that because I'm looking for test code here. Oh, we're doing spaces. I don't think it's that easy. Oh yeah, it is. Okay. So in the start, just say run less than sign and tell it what you want to read from. Hold on. Okay, so there's my segfault from before, and it told me this happened at line 39. Alright, so that thins it down a little bit for me. And my output location was 2912, and the character I was trying to store was my end of file. But my output array is not big enough to hold 2912 things.
Is /377 end of file?
Yeah, end of file is -1, which is a bunch of ones in FF, and hex is 377 in octal.
Whoa.
Why would it be an octal?
That's kind of what it defaults to. So the \377, you can say backslash and type in an ASCII code in octal, and it means that character. It's just a shorthand. But I don't know why they do octal instead of hex.
Yes.
A lot of people do octal.
Okay.
Did you have a question?
that was it.
Okay.
So I think that you answered it before, but I forgot what we were supposed to do if we have a phrase that is over 201 characters.
Just use the first 200 characters. Just
That's
save
it.
those.
You just
Yeah.
chop the rest off?
Yeah.
Okay.
Depending on how you do it, you might just keep the first 200 and chop the rest off, or I think my test code actually keeps the first 199 and then it just keeps replacing the 200th character with what it reads, or something like that. So my only War and Peace test is going to be to make sure you don't blow up and that you produce some sort of reasonable output. I'm not going to actually go through and check how many times each phrase is reported to make sure it matches. So.
Cool. And then, like, how thorough do you want our error checking to be? Like, if,
Well, what are the possible errors?
I don't know. Like, what if you just send semicolons and periods through?
That's okay.
Okay.
Yeah. I mean, so. Alright, so no output.
Oh, cool.
Alright, one phrase, hello. So yeah, you should be able to take all kinds of pathological looking inputs, but they're not really like errors.
Yeah.
It's just strange. So yeah, there's really no limit to how big your input might be. Right, ergo War and Peace. And yeah, I don't think there's any errors possible.
Is War and Peace still available? I was trying to access it yesterday.
Yeah, it should be on temp.
Who am I using?
Yeah, /temp/War and Peace. It's just uppercase W and uppercase P. So there we go. We can read. I know this first few sentences really well because I've been using this for test files for other things. I was using it on a speech recognition. So it was like reading this to me like over and over and over. But I don't know what happens in like paragraph 2.
Have you ever read it?
No.
Oh.
But I can read like a condensed version after you turn in PA4. It's only 1,000 lines long.
Question.
Yeah.
So how do you actually take that file from temp into your own?
You can copy it, or you can just read it. You can just say less than /temp/.
How do you copy it?
CD.
So here's my home directory. So I can copy /temp/War and Peace. I'll just call it WP, so I don't have to type in War and Peace. So now it's in my home directory. All right, WP.text. So CP source destination is how you copy files in Unix.
Okay.
So you just gave us a free one.
Yeah,
I guess it's public domain.
it's public domain. Yeah, it's from Project Gutenberg.
Are we allowed to put stuff in temp?
Yeah, you can put stuff in temp, but be a little judicious with it because it is a temporary area, and everybody can put stuff in there.
I was just thinking, like, if we find bigger sample text to test them out.
Yeah, if you want to donate it, pop it in there and tell people about it. That's cool.
Let's put the dictionary in there.
Yeah. So I've always wanted to do this. And counting phrases in the dictionary would be an interesting step. I always wanted to take the dictionary and like pick a word, take every definition in it, and look up the definition of each of those words. Come a little bit longer, look that up, and see if you either loop forever or you come down to like something with just like 2 words just repeated in a weird order that defines every word.
The definition of the.
Yeah. Be like the. I suspect you end up looping, or either you loop or you grow forever, or you find some kernel of like 5 words you need to know. Everything can be defined like that. I think it grows forever. But doing a phrase count in the dictionary would be interesting, right?
Yeah, let's do it.
Yeah, I know. Go for it.
Okay. How do I find how do I put a
That's some
text
data
file
analysis.
into temp?
So there's spelling dictionaries
Can I download
around.
the dictionary?
So yeah, you can download it, but there should be a spelling dictionary already on the system.
Oh, no way.
Yeah,
Wait, so we don't need to really do anything?
yeah. Just run your code.
Man.
Yeah.
Wait, can you do it now?
I'm not gonna take away your fun.
Okay.
But yeah, try that, see what you get.
Just like actually write a program that can like do the whole data analysis on the entire dictionary.
Yeah.
And see if you loop or blow up or whatever.
Yeah. That would be
Cool.
cool. Totally.
SLP?
That's an SLB, yeah.
Yeah, yeah. And then do it on different languages and see what you can learn about differences in
Whoa, like
languages.
if the
Do it
words
on
that you
all
end up with are the
languages.
same
Yeah.
thing, or if some languages have essential words and others don't.
Yeah.
Like
end up
one language it blows up
Duolingo.
and the other one is only words.
Yeah, yeah. Totally. You see this thing where somebody's teaching their dog to talk?
That's awesome. I saw that.
Yeah. They've got like a little soundboard with like 29 buttons, I think, and the dog can press a button and it speaks a different word.
Is this the same
And-
guy that like had his dog sit at the table and stuff?
No, this is a woman who studies linguistics, I think,
okay.
and like learning disabilities or something. But the dog is apparently being trained to like, if it wants to go outside, it'll press the outside button, and
Wow.
if it sees something cool outside, it'll press looking outside and stuff like that.
What the hell?
Yeah, that's good stuff. It's one of my life goals is to figure out how to talk to animals. So maybe we can use War and Peace as like.
That's some Rick and Morty.
Yeah, yeah.
You have
Yeah.
an open source like Git repository for it?
I haven't started it yet.
Oh.
It's when I retire.
Okay.
Yeah, I don't want to come home and find my dog reading War and Peace. That will not end well, I'm sure. All right, other questions? This is good. Hopefully this is helpful to people because these are the kinds of questions that I'm sort of seeing trickle in here and there, and any question that you can think of, right, will be on somebody else's brain also, probably several other people's brains. So it's good to talk about these here.
I asked really dumb questions. I'm glad they weren't that dumb.
They weren't dumb at all.
What type of like semi-new technology is part of common like CS learning now? Like neural nets, would we learn stuff like that in?
Yeah, you can take a machine learning class and learn about neural nets and deep learning and all that sort of stuff. Security is always an evolving area, right? That's up and coming. Languages, come and go. Python is a popular language these days, but
That's just because it's easy.
yeah, it found a niche with the scientific community, and that really sort of helped move it along. And it's found some other good application areas, and it's a modern language. It's object-oriented, things like that. But yeah, it's a good question. I mean, it changes all the time.
Quantum computing
Quantum computing.
is on the rise.
So yeah, and more
and
headlines.
they've got APIs for it already. So.
Hmm.
Is 4 years like enough to learn all this?
I don't think a lifetime is enough, but the more you learn, the quicker you are at learning things, and the quicker you are at deciding what do you want to learn, what don't you want to learn.
Once you learn one language,
Yeah, but
you
what if
learn
it's like-
all this
Yeah.
syntax.
It's all becoming so important, and I feel like I don't have enough time to.
How do you think I feel, man?
What can't you do in Bash that you can do in C?
It's not so much that Bash is limited, it's more that it's kind of quirky. It's in some ways less secure.
That makes sense.
You can do things that it will happily do for you, but will do things different from what you expected. C is similar, but not quite as bad. Java is kind of on the other extreme. It really won't do things unless you've really clearly told it something that it likes. If you say, so this famous thing.
Very rebel, by the way.
Hey, alternate universe.
Okay.
So C will happily do this. This will set I equal to 0 and then say that if condition is false. And it will never do these things, but if you print out the value of I down here, it's 0. And it's confusing, right? Because you meant I equal. So C will happily do this. Java won't. Java will say you can't do this.
Okay.
You're trying to do an assignment in there.
I've seen memes about errors popping up
Yeah,
in
yeah.
different images, and it's funny.
Yeah.
I see.
But yeah, as you said, right, at some point languages are really just languages. You learn assembly language, you learn C, you learn Java, you're in pretty good shape. Learn a functional language, right? And then, you know, somebody wants you to code in Python or somebody wants you to code in Lisp or something else, right? It's not a huge learning curve. It's largely syntax.
I get it now.
And after you've learned, you know, a few languages of each type, it becomes really easy to switch back and forth, depending on what somebody wants. If someone comes in and says, today we're going to program in Perl, you know, in this company forever, and so you learn Perl, and it takes you a day or two, then you're a Perl programmer. All right, so no class tomorrow for me. I am out all day. Thursday we will start talking about regular expressions. And you can get a little head start on it from the end of the previous section's video if you want, but we'll start from scratch on
Are we
Thursday.
gonna have any more ODPs for the rest of the week?
Probably, but I haven't done any yet, so.
I'm gonna be gone until Monday.
Okay. Oh, not for the rest of the week, no, but maybe next week.
Okay. Thanks, Nick.
Okay. Yeah.
So my index repository, I noticed that there's a branch. There's one branch, and I'm not entirely sure like what that